I know, right? I've once accidentally recorded people's grade, like on the Skyward. Yeah, I had it up and going. I didn't realize, and it was not good. Got a few mad parent emails. Okay, what in the heck? I swear this isn't the right first slide. Right here. Okay, everybody. So we know how to multiply x plus 2 to the third. We know it would be breaking the most forbidden rule of all forbidden rules, and we would never just square that, because that would not be correct, right? We'd have to write it out 3 times, and we'd have to multiply it out. This wouldn't be bad. We would multiply these two together, getting x squared plus 4x plus 4, and then we would then finally distribute in our x plus 2. That is very doable. But now, the bigger, the harder, the longer it takes. So what if I asked you to do x plus 2 to the 12? Now that the degree is so high, it becomes a quote-unquote daunting task. That would be hard, that would take a long time, and most likely you would end up making an error, getting it wrong somewhere. So there's got to be a better way, and there is. We're going to learn today how to multiply that out with some things that have been found over the years. So I'm just going to show you here, just looking here, this we don't need to write down. I'm trying to get you to see some patterns. So we have x plus y to the 0, that multiplies out to be 1. X plus y to the first multiplies out to be x plus y squared multiplies out to be that. X plus y to the cubed multiplies out to be that. X plus y to the fourth multiplies out to be that. Now let's look and see if we can notice some patterns here. The first thing I want you to notice is, this is important to see, degree 0 has 1 term. Degree 1 has 2 terms. Degree 2 has 1, 2, 3 terms, right? Degree 3 has 1, 2, 3, 4 terms. Degree 4 has 1, 2, 3, 4, 5 terms. So what can we say? Yeah, there's always going to be one more term than the degree. So we're going to call degree n. So there's going to be n plus 1 terms. Does everybody understand? So if I now test your knowledge and say, if I have an x plus y to the 12th, how many terms will there be? 13. Okay, that's important to know. Now another thing to notice is, let's just look at our powers of x and y. So first of all, focusing on x. So right here, let's start right here. X to the 4th, x to the 3, x to the 2, x to the 1, and then x to the 0. Does everybody see? Now x to the 3, x to the 2, x to the 1, x to the 0. X to the 2, x to the 1, x to the 0. Do you see how powers of x are starting at the highest degree and then just counting down? That will always happen. Now as that's happening, what's happening with our powers of y? They're going up. This is y to the 0, y to the first, second, third, and it ends on the degree. You guys see? Y to the 0, y to the first, y to the second, y to the third, ending with the degree. Once again, y to the 0, y to the 1, y to the 2, and done. Now also I want you to notice, so that will always happen, powers of x will decrease as powers of y increase. Then also, next thing I want you to notice is that all of our degrees will add up to be 4. Look, or for this one, 4. 4, 3 plus 1 is 4. 2 plus 2 is 4. 3 plus 1 is 4, 4. Do you guys see? So it always adds up to be 4. Right here is usually where you can catch, did I make an error? So look, degree 3, this one's 3. That's a 1, 3, 1, 3, and then a 3. Do you guys see? Yeah. That will always happen too. Then now let's focus on the coefficients. Coefficients means number in front of the variable. So what do we see happening here? This is a 1, a 4, a 6, a 4, a 1. Great. 1, 3, 3, 1. 1, 2, 1. Aren't the coefficients going up and down in the same pattern? Okay. Now we're not seeing, there isn't a pattern between from here to here with the coefficients. All that we're noticing is they go up and then back down in the same fashion. 1, 1, and then this one's obviously just a 1. That will happen. So now we're going to get deeper into these coefficients. Where do we get these coefficients? That brings me to what's called the binomial theorem we need to be writing down. NCR is this formula. N factorial divided by n minus r factorial times r factorial. So the coefficients of a binomial, now understand what we're learning today are binomials. Binomial means 2 terms. We're going to be expanding out, for example, x plus y to the whatever, 12. We're only learning, this only applies to binomials. Do you guys see what I mean? 2 terms, okay? So it says the coefficients of a binomial expansion are called the binomial coefficients. To find them, you can use the binomial theorem, NCR. We're going to talk about this, that you can calculate it n factorial divided by n minus r factorial times r factorial. So first of all, you can see NCR also written like this, just a side note, because you might see that on an ACT and stuff. So you might want to keep that in mind. I'm always going to write it like this. You'll always see it on my stuff as NCR like this. Okay, so first of all, this is true. 7 choose 3 will be equivalent to 7 choose 4, and we're going to see why that is. So I would write this down. NCR will always be the same calculation as NCN minus R. And once we put it up and you see the math, you'll see why this makes sense. Now, here is x plus y to the 7th. So this has to do with the coefficients of this. So first of all, the 7 is coming from degree 7. So 7, and then this is choose 3. The choose 3 part, you'll see where that comes from in a second. But do you see how 7 is for the degree, everybody? So that's always what you start with. That is our n. N is the degree. So n is degree. All right, so let's just calculate this first. Then I'll tell you why they're putting 3 there and why they're putting 4 there in a second. But let's just see how this formula works. So here we go. Let's plug it into our formula. So this would be 7 factorial divided by, I'm using this formula right here, divided by 7 minus 3 factorial. Do you see how I'm plugging it into the formula? Which would be 4 factorial and then times by 3 factorial, right? Well, isn't that going to come out algebraically the same as this one? Isn't this 7 factorial divided by 7 minus 4 is 3 factorial times by 4 factorial? Aren't they the same thing? Yes, multiplication can be reordered. Do you see how they would calculate to be the same thing? So let's calculate this by hand. So it's nice because once you know 7 choose 3, you don't have to calculate 7 choose 4 because you already know that they will be the same value. So here's how this works. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial means by definition. You just multiply all the way down to 1. So now we have a 4 factorial. So I'm going to write that right here. Isn't that 4 times 3 times 2 times 1? And then 3 factorial would be 3 times 2 times 1. So now just start dividing out things that can be divided out. Wouldn't our 4 factorial divide out? Then just start dividing more things out. I see it on bottom. I have a 6, don't I? And a 6 on top, so those divide out. So then left on top is 7 times 5, which is 35. And then divided by 1, so 35. So that is a coefficient, and I'll show you where it is in that expansion in just a second. But understanding the formula right now is what's important. So let me show you a quicker way to think through it, okay? Because we should not have to write out the 4, 3, 2, 1, because we're going to think more advancedly about this. We're going to go, okay, 7 factorial is 7 times 6 times 5, and then I'm not going to keep writing it out, because don't I see a 4 factorial on bottom? So I'm going to just say times 4 factorial, and I'm going to stop, because that's the highest factorial on bottom, and I know it's going to divide out. And then I have 3 factorial, so then I'll divide those out. Now I will do 3 times 2 times 1, so then now, once again, now we can simplify it. 6 and 6 divide out, so we get 35. So we'll just think more advancedly about it for the future, just like I did, so we don't write out extra stuff. Make sense? Any confusion? So where does the choose part come from? The 7 we get from the degree, but where does the choose come from? So let's look at an example here and you'll see where. So let's expand x plus y to the 5th, everybody. First of all, my question for you is, in x plus y to the degree 5, how many terms will we have? Remember back to our pattern. 6, right? We have 6 terms, right, everyone? So 1, 2, 3, 4, 5, 6 places, correct? We're going to have 6 terms. Now what we do is we start with 0. So degree 5, so it's always going to be 5, 5, 5, 5, 5, 5, degree 5. So 5 choose 0 would be our first thing. Oops, I wrote the 5 too big. Then this would be the second thing, then counting up, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and then we'll end in the same place that we started. So 5 choose 5. So we have to start with 0, everybody. That's important to remember. 5 choose 0. So notice the first term is 5 choose 0. The second term is 5 choose 1. Third term is 5 choose 2. Fourth term is 5 choose 3. So our choose part is 1 less than the term we're on. That's going to be important to remember. It's going to help us. And fifth term, right, is 5 choose 4. And then sixth term is 5 choose 5. One less than the term you're on. Now, we just talked about if we calculate this 5 choose 0, what will it be the same as? 5 choose 5, right? We just a second ago saw that 5 choose and this part. Oops, not across. NCR will equal NCN minus R, right, everybody? Did you write that down somewhere? Okay, so that's why, look, that's why 7 choose, wow, I hate how slow this thing is. So that's why 7 choose 3 is equivalent to 7 choose 7 minus 3 would be 4. You see what we did? Okay. So once again, 5 choose 0 will be the same as 5 choose 5 minus 0. Wouldn't that be 5 choose 5? So once we know this one, we know this one. So let's calculate this. 5 choose 0, that would be 5 factorial divided by 5 minus 0 factorial. You have the formula written down, so that would be 5 factorial times by 0 factorial. Now, any base to the 0 power is 1, correct? Not 0? 0 factorial works the same way. It's not a 0, it's a 1. So this is a 1. Isn't 5 factorial divided by 5 factorial a 1? So if this coefficient is a 1, then this coefficient is a 1. Doesn't it go up and down in the same pattern? Okay, also. Okay, awesome. Now let's calculate 5 choose 1. 5 factorial divided by 5 minus 1 is 4 factorial times 1 factorial. So now watch me calculate this. We would do 5 times 4 factorial. I'm going to stop because I see I have a 4 factorial on bottom. So then they divide out. So I have 5 divided by 1, which is 5. If this is 5, what will this one be? 5. Okay, we only have to calculate one more then. 5 choose 2, that would be 5 factorial divided by 5 minus 2, 3 factorial times 2 factorial. So to calculate that, I would do 5 times 4 times 3 factorial. I'm going to stop there because I have a 3 factorial on bottom that divides out. And then don't I have 2 times 1? Because I have 2 factorial. So then look, 4 and 2 divide out to be 2 on top. So 5 times 2 is 10. So if this one's 10, this one's 10. That's how we get our coefficients. 1, 5, 10, 10, 5, 1. There's our coefficients, the number in front of the variable from our binomial theorem. Now we can actually fill in the rest. Why? Because remember we saw a pattern here. Didn't the front thing start with the highest degree and count down? Yeah. So now we can fill in the rest. So right here would be x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then x to the 0. And then what did our second thing do? It counted from 0 up, didn't it? Y to the 0, y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, and then y to the 5th. So now I just have, there's my answer. That is the expansion of that. So I'll write it out prettier with plus signs though. So that's positive x to the 5th. Then we have plus 5x to the 4th y plus 10 x cubed y squared plus 10 x squared y cubed plus 5x y to the 4th plus y to the 5th. We just multiply that out, but not by physically multiplying it out. And it's in standard form. Isn't that cool? Yeah. Okay, awesome. So let's see if we're good with this one. It says, what are the coefficients of a plus b to the 4th using the binomial theorem? So what would you say? 4, degree 4 has 1, 2, 3, 4, 5 terms, doesn't it? So where do we start with? Degree 4, so that'd be 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and then 4 choose 4. Okay, awesome. Now from here we can calculate it. Fun fact, everybody grab your calculator. We could use our formula again or just use our calculator. It is okay to use your calculator. So everybody hit the math key. No, wait, actually hit this first. Hit 4, then hit math. Then go over to probability on your calculator. Go down to NCR. You've already typed in the N part. So hit NCR. and then type 0. Because then your calculator is saying 4, choose 0. So what do you get? 1. So now I can go in. I don't even need to calculate this one. I know it's a 1. Okay? Get your calculator. Do 4, choose 1. If you don't know how to do it, ask your neighbor for help on your calculator. Ready, go. 4, choose 1 is? 4. Okay. So I know this one's 4. And then 4, choose 2. 6. There's our coefficients. I'm okay with you using the calculator. It is nice to see how the formula actually works, though. Okay, now let's fill in the rest. What's our front thing? A? Yeah, so we'll do a to the 4th right here. A to the 4th, a to the 3rd, a to the 2nd, a to the 1st, a to the 0. So I'm not going to write it. Then we'll take our back thing, b to the 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th. Now here's one thing you should check. Before you simplify it, it should be 4. Oops, let's not do the same color there. Let's change the yellow. 4, 4, 4, 4, and 4. It is 4 because that's a 1. You guys see how they're all 4s. So now your final answer would be a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. And we've just multiplied that out. Isn't that neat? Cool. So, now here's a fun fact for you, okay? So Pascal is a mathematician back in the day, and he started out multiplying out different binomials. He multiplied out a bunch of different binomials. And he started to notice something interesting. This pattern for the coefficients is always happening. He was able to see that every time he was multiplying out all these different binomials, and he saw that every time this is the pattern. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Do you see it right here? Just the coefficients being written out. 1, 4, 6, 4, 1. This pattern always happens when multiplying out binomials. So where did that come from? Well, let me show you. We can create Pascal's triangle by doing such. Notice all on the diagonal are all 1s. Does everybody see? Yeah. Then here, right here, we have 1 term, 2 terms, 3 terms, 4 terms. That's always going to happen. Now, how did they get the 2? Well, you just add the 2 terms above it. 1 plus 1 is 2. Now look, 1 on the diagonal. 1 plus 2 is 3. 2 plus 1 is 3. 1's on the diagonal. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Do you guys see where they're coming from? So we can continue this onward and outward forever. And these coefficients are always happening. So let's create Pascal's triangle. You have to be able to create it from scratch. So ready, start going. Start creating Pascal's triangle. So you'd say 1. Then I put on my diagonals 1. Keeping your work really nice and pretty, because when you get off is when it's kind of hard. Writing small on 1 sheet of paper. Start creating it. 1, 2, 1. Don't look up here unless you need to check your answer. You have to be able to create it on the test. 1, 3, 3, 1. You add the 1 above it. 1, 4, 6, 4, 1. And just keep creating it for a while. So as you're writing it out, think about this. Pascal's triangle is just another way of getting the coefficients, but much quicker. We could use the Binomial Theorem, which is what we just learned, or we could use Pascal's triangle. Okay, that's a valid question. So people are saying, how far out should I go? So let me point something out, though. Everybody, this is important to note. This is not degree 1. There's 1 term, it's degree 0. This is x to the 0. This will be x to the 1st, right? 1 will have 2 terms, right? This is x squared, x cubed, x to the 4th, x to the 5th, x to the 6th, 7th, 8th, 9th. So I've gone out to x to the 10th. Now what else can I point out to you that kind of helps you know if you are in the right place? Do you see how degree 2, the second thing is is a 2? Degree 3, the second thing in is a 3. Degree 4 is a 4. Do you guys see? 5, 5, 6, 6. Yes? Okay. Sweet. Okay, so I go out to 10 at least. So So this would have been 1, choose 0, 1, choose 1. This would have been 2, choose 0, 2, choose 1, 2, choose 2. It's just a quicker way of seeing these patterns instead of having to use the binomial theorem. This would have been 6, choose 0, 6, choose 1, 6, choose 2, 6, choose 3, 6, choose 4, 6, choose 5, and 6, choose 6. Just trying you to make the connection here. It's another way of getting the coefficients besides the binomial theorem. Now there is a reason we use the binomial theorem, which you'll see in a second. It's going to help us when we do something like, if I was to ask you to find the, I'm going to go back to this one. Look at why the binomial theorem would be useful. If I said to you, find the third term, in expansion of this, x plus y to the 5th, you wouldn't want to have to do out the whole thing, you know? And if I said use the binomial theorem, you would just think. You'd say, okay, what am I going to be at? So if it's the third term, you'd say first, second, third, we need the third term. Wouldn't this be 5, choose 0? 5, choose 1, this would be 5, choose 2, and then you'd say x to the 5th, x to the 4th, x to the 3rd, and then we'll have y to the 0, y to the 1, y to the 2nd. And then you would just type that into your calculator and you'd be there. Does that make sense of why the binomial theorem would be useful? Okay, awesome. Now let's use Pascal's triangle to actually do out the whole thing. Pascal's triangle we only want to use if we have to do out the whole thing, expanding the whole thing. So my problems are coming off your homework. Number 1. Here we go. So the first thing you would do is say, okay, what are the coefficients? So you would go to Pascal's triangle and go to degree 4. Remember that's not, it starts with 0. So what is the coefficients for degree 4? 1, 4, 6, 4, 1. I left myself plenty of room to fill in the rest. Now our front thing, guys, is x. Take your front thing, start with the highest degree and count down. That's always what we do. So this will be x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. Now let's take the back thing, and you'll do that backwards starting with 0. So this will be 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th. Then before I move on, I check, before I simplify, do they all add up to be the degree? 4, 4, 4, 4, and 4. 1 and 3 is 4, right? So they're all 4. It's a way of catching yourself to see if you've made any errors somewhere. Okay, now let's actually simplify this. Now being very careful. The front thing is 1x to the 4th, isn't it? Yeah. So that'll just be x to the 4th. Cross it out. Moving on. Now look, people have a hard time right here for some reason, but don't. We are multiplying all this together. So wouldn't it make sense to reorder it? Isn't that 4 times 2 times x to the 3rd? 4 times 2 times x to the 3rd. That would be plus 8x to the 3rd. Now reordering this, we have a 6 times 2 squared, so 6 times 4 is 24, and then we have our x squared. 4 times 8, right? 32, x, and then 2 to the 4th is 16, so plus 16. And look at that, it puts it right in standard form. We've just multiplied out x plus 2 to the 4th. Sweet stuff. Okay, let's do another one. Do you want to do this one, or would you rather move on to where we have negatives? No. Do you need another easy one, or you guys get the picture with the easy one? Get the picture with the easy ones? How many terms would this have? 8 terms, and we would just put in our coefficients, and we just do 8 to the 7, 6, 5, 4, 3, 2, 1, 0, right? The back thing, 2 to the 0, 1, 2, 3, 4, 5, 6, 7. Okay, awesome. Let's go on to number 4. Negatives, you've got to be extra careful. There's a little bit to think about. So, degree 5 has coefficients 1, 5, 10, 5, 1. Am I right? Or am I missing something? Yep, missing a second 10. 10, 5, 1. How I knew that was, once again, I counted, there should be 6 terms. 1, 2, 3, 4, 5, 6. Okay, awesome. When you're looking at your Pascal's triangle, I'm doing it off memory. Oh yeah, we're going to make it 5 to make it easier to start out. Good point. I remember that's what I changed it to. So we're going to do it just to the 5th because to start out with an easier one, to see the negatives. Okay, good point. So now let's start. Our front thing is D. So you have a D to the 5th, 4th. I'm doing it underneath because it's too squishy. D to the 3rd, D to the 2nd, D to the 1st, and then D to the 0, right? The next thing I need parentheses. So negative 2 to the 0. This will be negative 2 to the 1st, negative 2 to the 2nd, negative 2 to the, counting up, 3, negative 2 to the 4th, and then negative 2 to the 5th. Does everybody see? 5, 5, 5, 5, 5. So we're good here. And a 5. Okay, awesome. Let's start calculating this. We have a 1 times d to the 5th. Wouldn't that be d to the 5th? Cross it out. Now right here we have a 5 times negative 2 to the 1st. Negative 10, and then we have a d to the 4th. I'm just multiplying straight down. Do we understand that? We're being extra quiet. Now right here we have a 10 times a negative 2 to the 2nd. Won't a negative to an even be positive?
Yes.
So that means it's going to bounce back and forth between positives and negatives, won't it?
Yes.
It'll bounce between even and odd degrees. So our negatives, if we have a negative, will always bounce. That's another way to catch your error. Okay, so we have positive 40 though, right? 40 d cubed, yes. Then we have a 10 times negative 2 to the 3rd. That would be negative 80. Negative 2 to the 3rd is negative 8. Times 10 is negative 80. D squared. Then we have a negative 2 to the 4th times 5. So plus 80 d. And then our final thing is negative 2 to the 5th, which is negative 32. Now check. Is it bouncing between positive, negative? Positive, negative, positive, negative, positive, negative. Yes, we're good. And it has 6 terms, so we're good. And another, okay, so where people usually mess up is they don't actually raise this to the power. Let's do a few more. It gets harder, a little bit harder. Same idea, it's just being careful. Let's do this one. Number 5, 2x minus 3 to the 4th power. So that's 1, 4, 6, 4, 1. Take your front thing. Now this front thing has a 2 and an x. This is really important. We don't want to miss, these are easy problems, but even last hour I was seeing people were having a hard time multiplying these out, right? So let's be really careful. So we start with our front thing and do the highest degree. So both 2 and x are raised to the 4th, right? Yeah. Both 2 and x to the 3rd, both 2 and x second, 2 and x to the 1st, and then 2x to the 0. Our back thing is a negative 3. We better use parentheses. So we have a negative 3 to the 0. I don't know why I wrote it. Negative 3 to the 1st, negative 3 to the 2nd, negative 3 to the 3rd, and negative 3 to the 4th. Checking my degrees to make sure all looks good. 4, 4, 4, 4, and 4. Okay, all is good here because it was degree 4. Okay, let's start calculating this. Now, what people have a hard time with is they'll not do 2 is also raised to the 4th, people. Do you see? So you have 2 to the 4th times negative 3 to the 0, but negative 3 to the 0 is 1. Okay, so we have 2 to the 4th, right? 2 times 2 times 2 times 2. 16x to the 4th. Now right here we have, 4 times 2 to the 3rd. Times negative 3. Does everybody see? So that's 4 times 8 times negative 3. That's negative 96. Negative 96, and then we have an x to the 3rd. Now we have a 6 times 2 squared times negative 3 squared. So that's 6 times 4 times 9. So plus 216x squared. Then right here, it's bouncing between positive, negative. Positive, the next one should be negative. So we have a 4 times a 2 times a negative 3 to the third. So negative 216x. And then negative 3 raised to the 4th power is plus 81. Positive, negative, positive, negative, positive, negative. Positive, negative. Okay, sweet. Look at that. So usually where people make the errors, they don't take the 2 to the 3rd power. Do you think you could do one with 2 variables? Same idea, right? You just got to use parentheses, but make sure you raise both the 3 and the m to the 3rd power. Okay? So before we move on, last thing. Here is on 21, I need to see you using binomial theorem. Once again, what if on the test I said that this was degree 20? You don't want to have to go out that far on Pascal's triangle. 10 we got, but do you get what I'm saying? So let's do this. Let's think about it. It says, find the 3rd term of this. So first of all, the 3rd term. So we're in 3, right? Here's all we care about, right? So wouldn't this be 10 choose 0? 10 choose 1, 10 choose 2. 10 choose 2. All right, now that's going to be our coefficient because we're not using Pascal's triangle. Everybody? You get what I'm doing though? Yes. Then right here would be x to the 10, 9, 8, wouldn't it? So we have an x to the 8th. Then we're going to have a 3 to the 0, 3 to the 1, 3 to the 2nd. So let's calculate this. Do 10 choose 2 times 9. In your calculator, 10 choose 2. Type it in. Times 9. 405? So this would be 405x to the 8th. That would be the 3rd term of expansion. Okay, sweet. Except for it's not. It's not 405.
What?
You guys, it's 10 choose 2 times 9, right? We have a 9.
Well, 10 choose 2 is 45.
Where am I messed up then? Oh, on the actual homework is 12. No wonder I'm having issues. So it is 405 for my problem, which is not the correct problem for your problem. Okay, awesome. Just making sure we can calculate it right. That's the key. Okay, awesome. So this would have been 12, so that's why we were having issues. So this would have been 12 choose 2, right? 12 choose 2? But that's okay. We get the picture. Just making sure. Okay, awesome. So what I want you to do is, all you have to do is work in class. That is all that's required. You have to go pick the hardest looking problems on here. If you miss this on the test, you're missing the easy problems. But I'm telling you, it's doing it by yourself.